Okay, here's the problem solving video for problem 269. You can see there circuit there. The problem statement says if the power supplied by the 3 amp current source is 12 watts, find Vs and the power supplied by the 10 volt source. Okay, really we're going to use Kirchhoff's laws here to work this problem and Ohm's law. The first thing we need to determine is the problem starts off and says the power supplied by the 3 amp current source is 12 watts. We remember P is equal to V times I, so that's going to tell us that the voltage across that current source is 4 volts. Now, what polarity should it have? If we remember that when we have a box like this, satisfying the passive sign convention, that gave us power absorbed. So when we have current entering the plus and leaving the minus, that's power absorbed. So the opposite would be the current leaving the plus. So in this case, since this is supplying, there's a voltage of 4 volts across that current source with that polarity. Has to be that polarity because the source is supplying 12 watts. So if we look at that, 4 times 3 would be 12, and supplying the voltage has to be that polarity. Now we can calculate the voltage across the 4 ohm resistor, and by Ohm's law, we know that's 12 volts with that polarity. So from Ohm's law, 3 times 4 is 12, that's the polarity. Okay, now, you say, well, okay, what can we do at this point in time? Well, let's look at this source and this resistor. We know the voltage across this resistor is 10 volts. So that current has to be 2 amps. Okay. We know there's 3 amps entering here. We could use Kirchhoff's current law at this node if we knew this current or this current. Now, if we look at Kirchhoff's voltage law around this loop, okay, and let's define this voltage as Vx. So if we applied KVL around this loop, starting here and going around clockwise, we'd have minus 4 plus 12 minus Vx equal to 0. Therefore, Vx equals to 8 volts with the polarity shown. We just used Kirchhoff's voltage law to get that. Now, by Ohm's law, then, we know that that current is 2 amps. Okay, so we got the 8 volts from Kirchhoff's voltage law. So here we're just going to kind of systematically apply Kirchhoff's voltage law, Kirchhoff's current law, and Ohm's law. So now we're ready. If we apply Kirchhoff's current law at this node, we got 3 amps entering, 2 amps entering is 5 entering, we got 2 amps leaving. So that says it has to be 3 amps leaving, flowing into the 10 volt source. Now, this is satisfying the passive sign convention. Current's entering the plus, leaving the minus. So the power 10 times 3 is 30 watts absorbed. So the 10 volt source supplies minus 30 watts. Okay, since it's absorbing plus 30, it's supplying minus 30, and the current has to be flowing in that direction to satisfy Kirchhoff's current law at that node. Now, if we go back to this node, if we look at the currents, we know this current, this current. If we could calculate this current, then we could find that current. Now, let's apply KVL around this loop to calculate this voltage, and I'll just call it V sub Z. So if we start here at the red circle and go around clockwise, we'll have Vx, which is 8, plus 10, minus V sub C is 0. Therefore, V sub Z must be 18 volts. Again, that's just an application of Kirchhoff's voltage law. And then from Ohm's law, that current has to be 3 amps in that direction. Okay? So now, we have 3 amps in this direction leaving, 2 amps here, 3 amps here. So all these are leaving, so there's 3 plus 2, so that says there has to be 8 amps flowing into that node, okay, because there's 3 leaving here, 2 leaving here, 3 leaving here, so there has to be 8. From Ohm's law, that tells us that that's 24 volts. So now, if we apply Kirchhoff's voltage law around that loop, we'll get Vs is 24 plus 18, which is 42 volts.